We've just finished talking about, well, some of the basics in QoS. You mean there has to be a part 2? Yes, there does. Find out more right here on IT Pro TV.
You're watching IT Pro TV.
We are taking a look at Describing QoS Part 2, The Revenge of Anthony Sequeira. And so here we go. Anthony Sequeira, we are in a Part 2 on QoS. We've already talked about latency, jitter, delay a little bit, marking a little bit, but we have more?
We do.
Okay, lay it on us, Anthony.
Yeah. Well, the first thing we need to do is we need to pick up on a point of confusion from the last episode. Corolla, if we could, thank you. Go to my screen here. Look at this. I was all completely thrown off. Ronnie was like, well, how do the bits lay out? And why are you only describing 6 of the 8 bits? That's because there is a typo here. This is not 4 bits. This is 6 bits. So if we are using an IP precedence approach to marking, it's using the first 3 high order bits and it's doing nothing with the 5 other bits. No. In a DSCP world, we'll use all the bits. The first 6 are your DSCP bits, and then the next 2 is for explicit congestion notifications. So there's the explanation on that confusion. And we love, as we said, the DSCP approach, Ronnie. Now, I also wanted to give you my analogy, Ronnie, for classification and marking that we talked about last time. We love classification and marking as that initial step of QoS. And my analogy that's perfect for us here in Florida is theme parks.
Right.
What do you love to get at a theme park if you can afford it? The Fast Pass.
Yes.
You
definitely
are now classified and marked, and you get a special lane, and you don't have to wait 2 hours for Harry Potter and his wonderful wizarding world. Wizarding.
Yeah.
I think I mispronounced it even. Not my thing, but I did have to take my daughter, and I'm too cheap for a Fast Pass. So we were scavenger traffic, and we waited 3 hours for that 10-minute ride on a broomstick or whatever we were doing. Anyways.
You sound bitter.
I'll deal with my issues later. But so classification and marking, just think about that Fast Pass at the theme park.
Great analogy.
That's my favorite analogy on
like
that
it.
one. All right, well, let's jump into the current stuff that we have to cover. And that is going to be a continuation on our discussion. And I wanted to start by reviewing a little bit with you the markings that were so important. And to do that, I wanted to impress upon you how wireless is often configured. In Cisco wireless environments, they have us categorize the traffic in our SSID, in our Wi-Fi network, as platinum, gold, silver, or bronze. Bronze being the kind of scavenger stuff, the stuff that gets background bandwidth. So notice it's AF, Assured Forwarding Class 11, that is used. That gets a numeric value of 10, and yes, that is referring to how the bits are set, by the way. That's pretty cool. Silver class might be best effort, unmarked. Gold class, maybe that's reserved for video and it gets an assured forwarding of 41. What did we say about voice? It always should be marked expedited forwarding, and sure enough it is. It has a decimal value for 46 at the marking, and it's that expedited forwarding. So notice, inside a wireless QoS environment, even though it's wireless, we're still going to be classifying, marking, and then treating traffic differently based on those markings.
Now, Anthony, I've seen numbers, at least on blogs and different things, where they've described like the expedited forwarding as DSCP 46. Is that the same marking that we're talking about?
That's what they're saying. Yep.
Okay.
There's kind of a lazy way to say expedited forwarding. But yeah, if you wanted to give details, you would say, oh, that's DSCP marking of 46.
Okay.
That's right. By the way, I should have said this up front, Ronnie. You know, QoS, it's one of those topics, and I am not kidding you. Ronnie and I could do easy 60 episodes on QoS. I'm not kidding. It reminds me of BGP. if you really wanted to cover BGP in the scope that it could be done, it could be 60 episodes.
Easily.
So that's one of the, don't let that frustrate you, okay? Just recognize the fact that, oh my gosh, this is a very deep subject. And, just don't let it frustrate you. I've always just kind of embraced the fact that like, wow, I'll never be an expert in any of these technologies. I'm just going to like try and learn, as much as I can. I would love to just teach QoS for a living. I love it that much, but unfortunately can't do that.
All right. So Anthony, now that we understand a bit more about the classifying and marking, especially with your analogy of the fast pass, that's a great analogy to think about.
You're ready to punish some traffic.
So let's talk about this idea and these strange terms, okay? So the strange term that we normally hear, of course, is policing and shaping. Is that?
Yeah.
Okay. So
I love these terms because when we think of police, unfortunately, I want you to think police brutality.
Police brutality.
Yeah. Unfortunately, okay. I know I'm not making light of that.
Right.
I'm just saying that just think that the police is going to be like, sorry, you're speeding, and they are going to write you a ticket.
Okay.
In QoS terms, it means you're typically going to drop or remark traffic. So you've got someone trying to send too much traffic. Maybe it's gaming traffic, and you have said that's low priority traffic. And you've got this WAN link, and they are hammering your WAN link with all this traffic. In a traffic policing environment, the excess traffic is typically dropped. You could remark it. So you could say, oh, I see you're assured forwarding 11. We're going to mark you down so you can, and then the idea there is the next hop will punish the traffic that has that reduced marking. But the most common policing configuration is to drop excess traffic. Shaping, it's kinder and gentler. It doesn't drop traffic. It says, hey, I'll just buffer you so that when the interface is less busy, I'll send you. And that makes sense by the name, right?
Yeah.
It's trying to make a more smooth traffic shape, and it's not as strict as policing. Now, what is going on this slide, Ronnie, where we have single rate 2 color, single rate 3 color, 2 rate 3? These are all different types of policers. And here's what the colors mean. The 2 color versus 3 color. That is, let it pass, which the cop can do. I haven't seen it in a long time, but sometimes they go, hey, kid, drive slow, move on. And they don't give you a ticket.
Right.
It's very rare. The policer can do that inside QoS. So it can pass the traffic, or it can drop the traffic, or it can remark the traffic. That's what we refer to there as colors, different treatments. And then the 1 rate versus 2 rate, that is whether we allow excess burst.
Okay. So
you could say, look, we'd like things kept to this rate, but we understand that sometimes there's going to be, a lot going on. So we'll allow bursting above that rate. If you permit that, that's what's called a 2 rate policer. Okay. So it's just different words to describe different types of traffic policers that we're going to run into. Now, what most people think of QoS is this slide right here. QoS is an incredibly vast topic. As I told you in this episode, I could do 60 EPs on this, easy. What most people think QoS is this, congestion management, but you already get a sense for it's way more than just this. Now, this has gone through kind of generations, and that's how I listed them as like early on, all we did was first in, first out. Yep, first packet in, first packet out. And then they came up with the idea of let's put packets into different queues and round robin between the queues. And then they came up with, this will be fancy, weighted round robin, where you could take your voice traffic and go, one of those packets goes, one of those packets goes, one of those packets goes, and then I'll go to the other queues. And then another one, another one, another one. And you see what's happening. That's getting more attention than the other queues. But that led to problems. Queue starvation. There's a queue out here that's like starving.
Right.
So they came up with custom queuing, and then priority queuing, and then weighted fair queuing.
That last one.
Yeah.
That next to last one is killing me.
The next to last one?
Yeah,
Class-based weighted fair queuing.
Yeah.
And here's the deal. We don't do any of the early methods anymore. The whole world really comes down to class-based weighted fair queuing or low latency queuing. And really, it's as simple. If you were using voice over IP, you do LLQ, because LLQ gives this really strict priority class to the voice and then does class-based weighted fair queuing automatically for everything else, and it works great. If you're not using voice, then you could use class-based weighted fair queuing. But those last two, they're the congestion mechanisms of the future.
So help me out here. With the congestion management, that doesn't take place, even the low latency queuing, unless we do have congestion, correct?
Very good point.
Okay.
If you don't have congestion, well, then it's FIFO, because there's plenty of bandwidth for all, and the packets are just, line speed going out. Great point.
All right, so with the management, we kind of understand what we're trying to do, since you've actually kind of described that. But there's another term that we also need to talk about here, which is the idea of avoidance.
Yeah, CA,
so,
congestion avoidance.
So congestion avoidance, congestion management, it doesn't really sound like much difference. Is there a lot of difference here?
There is.
Okay.
So you said correctly, Ronnie, the congestion management tools only kick in when there's congestion. Congestion avoidance, let's not have congestion at all.
Okay.
Let's avoid having to do the low latency queuing. Let's not have congestion. And there have been two approaches: random early detection, or now what we all use is the better version, weighted random early detection. And you see the Star Trek logo.
Yeah.
What
yeah, you've got to actually,
all right.
I'm assuming it's an analogy.
John is a big Star Trek fan, right?
He is.
One of our founders.
Deep Space Nine. Deep Space Nine.
Okay.
He loves that one.
All right. I'm a casual Star Trek fan. I remember one of the movies, right?
Right.
And Spock, I actually started crying. It was an effective scene. I cried.
Right.
Spock was in some like radiation chamber, and he was going to stay in there so that he could save the entire ship.
The Wrath of Khan.
Okay. In that movie, he went up to the glass, I remember, and was talking to Kirk, right? And he was like, Captain, it's logical. Like, the good of the many outweigh the good of the one or the few. And I started crying. And then I realized, oh my gosh, that's weighted random early detection.
Right.
What we do is we sacrifice
Okay.
low priority packets
All right.
for the good of all the packets. So isn't that amazing? That's how this works.
Yeah.
So one of the Facebook packets comes up. Sorry, Facebook. One of that comes up, and the queue is starting to get congested. So this notices that. We're getting close to congestion. So weighted random early detection takes that Facebook packet and randomly chucks it. So it's getting rid, it's sacrificing low priority packets. And I guess that's where my analogy breaks down a little bit. Spock is far too important. It should have been one of those guys in the red shirts that they always beam down to the planet first that get eaten by the monster. One of those guys should have been in the radiation chamber. But anyways, you get the idea. So what a fascinating concept. Low priority packets getting sacrificed for the good of everyone else. And that's how weighted random early detection works.
All right. Now, I noticed that as we start to move through our concepts on QoS, I'm seeing an acronym that I don't know if anybody might actually be super familiar with this. LFI. What are we talking about?
Yeah, I was surprised that this was not covered in some of the Encore materials that I saw. It should be. This is a very real thing that's still used today. This is link fragmentation and interleaving, and we often put it in a category of what we call conditioners. You know what would be another line conditioner or QoS conditioner? compression.
Okay.
That's
Right.
that's a valid QoS thing. Oh, don't send that big, text file. Compress it down and send it. Link fragmentation and interleaving is a great technique on real low-speed links. And I guess that's why authors are starting to drop mention of this. They're like, well, everything's high speed now. Not in some of the networks I visit, especially overseas. Like I said, there's frame relays still pumping away in some town in, I don't know, a country other than my own. I bet you there's frame relay running here in the US.
There probably still is.
Sure. All right. Enough of that tangent. Link fragmentation and interleaving. Ronnie, you're going to love this. We got this big packet coming through, and it's about to hit this really slow speed WAN link. The LFI QoS mechanism goes chop, 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 chop. It fragments that big packet, and it interleaves. Link fragmentation and interleaving, it interleaves something like the voice packets, so they don't get stuck behind this huge packet. They get woven into that packet that was intentionally fragmented. So that's LFI. And that's, I think, the last of the QoS features. So let me try and recap this, Ronnie, and correct me if I'm wrong. We have classification.
Right.
We have marking. We have traffic shaping or policing. We have congestion management, congestion avoidance, and then we have potentially conditioners. And there's your full gamut of differentiated services, quality of service topics.
All right, Anthony. Well, thank you for helping us through these 2 episodes here on QoS, and with a big, gigantic description of a bunch of technology to make sure you take advantage of both of these episodes, watch them through a couple of different times, and ensure that you understand the concepts that are actually presented here. But there is, of course, more Encore to come, so it's a great place for us to go ahead and sign off. For IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned for more episodes right here on CCNP Encore.
Thank you for watching IT Pro TV.